Hello students, welcome to the session. Today's topic for the session is differentiation of algebraic expression of type x to the power n. So we will see the differentiation of this x to the power n. See, first of all, we should know the notation for x to the power n. We will write like this: d by dx of x to the power n. So this is the notation. D by dx, derivative of x to the power n. X to the power n will be, the derivative of x to the power n will be n x to the power n minus 1. Okay, so what we will do, we will bring that power n, okay, beside the function value x, and we will reduce the power by 1. So n x n minus 1 will be the derivative of this expression. Okay, so let's see some examples. If it is d by dx of x to the power 10, so what we will write, we will bring the 10, okay, then we will write x to the power 10 minus 1. So it will be 10 into x to the power 10 minus 1 is 9. So 10 to the power 10 into x to the power 9 is the derivative of x to the power 10. Okay, if they ask derivative of x to the power 50, so that means bring the power 50 and x to the power 50 minus 1. So it will be 50 to the x to the power 49. So first thing, what you have to do, you have to bring the power in the base and then reduce the power by 1. So you will get your derivative of x to the power n type of expression. Okay, let's see some examples. Now if you have 3x square, okay, now you have 3x square, now you have to derive 3x square. So derivative of 3x square, so that means, see, it is a scalar, okay, so we can, and it is scalar, and both the expression, this expression 3x square, they are in multiplication, okay, they are in multiplication. So we can take our scalar out from the derivative area. Okay, so we can take our scalar out from the derivative area. So this will be, now this expression will look like 3 d by dx of x square. Clear? So this is 3 into x square, derivative of x square. Now we know what is d by dx of x to the power n. So it will be n x to the power n minus 1. That means 2 into x to the power 2 minus 1, that is 1. So this is your 3 2 is a 6, 6x. Clear? Now if you have expression, these are the single terms, okay, if they are in single term. But if you have expression like y is equals to 10 t square plus 20 t cube. Now you have to remember here that your function y, y is in terms of t, y is in terms of t, that is y is a function of t. Okay, so y is a function of t, so we have to differentiate this y with respect to t. Okay, so whatever the function is given in terms of any type, so we have to differentiate that given function with that type. Okay, so since y is in terms of t, so we will differentiate y in terms of t, so it will be your dy by dt. Okay, so dy by dt means, now we will take here d by dt of y, we will read as d by dt of y first, then dy by dt. Now right side also we have to differentiate with respect to t, and we will write the expression like 10 t square plus 20 t cube. Yeah. Now we will take the differentiation d by dt to both the terms. There are two terms. We will take the differentiation to both these terms. So this will be d by dt 10 t square plus d by dt of 20 t cube. So this will be, now again your scalar multiplication is there. You can bring this 10 out of the d by dt area. So this will be 10 d by dt t square plus this 20 is in scalar multiplication. Take this 20 out of the the differentiation area, so 20 d by dt t cube. So this will be your 10. Now again applying that rule, x to the differentiation of x to the power n is your nxn minus 1. So here bring the 2 to the base, multiply it into t and reduce the power by 1. So it will be 1 plus 20 into t cube means again differentiation of t cube is bring the power 3 to the base. Now it is 3 minus 1, that is 2. Now it is your 20t plus 60t square. So this is the differentiation of this expression. So first thing you have to remember that whatever the function is given in terms of any other function, you have to differentiate that function with the given function. What is the representation of the function in terms of that function? You have to differentiate. You have to be here very much careful. Okay. Now, if you are, let's see some other example. If you have a y function as y is equals to x cube plus 1 by x square minus 1 by x, where x is non-zero. Clear? Where your x is non-zero. Now, see, you have to differentiate with respect to, since the y is in terms of x, so we will differentiate the y function in terms of x. So we will write differentiating with respect to x. Okay, so before starting the differentiation, let's simplify the expression. Okay, let's simplify the expression. Why it is needed to simplify the equation, because see here it is 1 upon x square. The power expression, the power of the algebraic, the expression is in denominator. So but we have learnt that t by dx of x to the power n in numerator version. We have learned the numerator version. We don't know the denominator case. So what we will do, we will bring this to the numerator by changing the exponent, by changing the power. So it will be x to the power 3 plus x to the power minus 2 minus x to the power minus 1. Now this expression is matching to x to the power n type. Now this is x to the power n type. See, it is also x to the power n type, but it is in denominator. So we cannot apply that rule by differentiating here. Okay, we cannot apply that d by dx here in the denominator. So for that, if we want to apply this, we need this in the numerator. Okay, that's what we did. Y. So y is x cube plus x to the power minus 2 minus x to the power minus 1. We just simplify the given expression. Now we will differentiate with respect to x. Now it is d by dx is equals d by dx of x cube plus x minus 2 x to the power minus 2 minus x to the power minus 1. Now since d by dx of 3 terms, we will take individually differentiate the terms x cube plus d by dx of x to the power minus 2 minus d by dx of x to the power minus 1. Clear? So d by dx of x cube. So we know the power rule. Okay. So this will be 3x to the power. The power rule says that n minus 1. So this is 3x, 3 minus 1, that is your 2 plus d by dx of this, d by dx of this. That means again we have to bring the power in the base and reduce the power by minus 1. Minus 2 minus 1 will be your minus 3. Now x to the power minus 1. Now bring the power to the base, minus 1, x to the power minus 1, that is minus 2. Now we will simplify the expression. 3x square minus 2 by x cube plus 1 by x square. Clear? So this is our final expression dy by dx. So we should write our expression in positive powers only. Okay, positive powers. It is the simplified and final answer. Clear? So what we should know? We should know that our x to the power n expression should be in the numerator. So only at that time we can differentiate that expression, not in the denominator. If it is in denominator, bring it to the numerator by changing the exponent, by changing the power. Okay. Now let's see another variation. What if they are saying that phi is equals to x cube plus 3x square plus 4x plus 5. Find dy by dx. Find dy by dx at x equals 1. Okay, find the dy by dx at x equal to 1. Now see, first you have to find the dy by dx. Then they are asking find the dy by dx. Not only dy by dx. Now they are asking dy by dx at particularly x equals to 1. Particularly x equals to 1. Now we know the x to the power n rule. Okay, so we will differentiate the given expression like this: d by dx of x cube plus 3x square plus 4x plus 5. That means your d by dx of x cube plus d by dx of differentiating individually each terms plus d by dx of 4x plus d by dx of 5. Clear? Now d by dx power rule, apply the power rule here. 3x to the power 2 minus or 3 minus 1. 3 minus 1 will be 2. Okay. Now scalar multiplication is here. So bring the scalar out of the differentiation area. So it will be 3 and d by dx of x square plus 4. Bring the 4 out of the d by dx area. So it will be d by dx of x. And the constant differentiation is always 0. So constant differentiation, constant means there is no term, no variable here. So constant differentiation is always 0. So that means your expression is 3x square plus 3. dy dx of this will be 3 into 2x plus 4. The differentiation of x with respect to x is 1. How? So 1. So it is in 1. So bring the power 1 in the base. And what we will do, reduce the power. So x, it will become 1 minus 1, 0. The power, it will become x to the power 0. So answer will be 1 directly plus 0. No change. So 3x square plus 6x plus 4. This is your dy by dx. But what they are asking? They are asking to find the value at x equals to 1. So particularly they are asking dy by dx at 1. So my dy by dx is this, but at x equals to 1. So my dy by dx at x equal to 1 means I will put x equals to 1 in the given expression. So this will become 3, 1 square plus 6 into 1 plus 4. So this will become 3 plus 6 plus 4. That is your 3. Clear? So they are asking both dy by dx also at x equals to 1, particularly at x equals to 1, they are asking the value. Okay. So let's see another example. If it is f of x equals 16x plus 2, now find f dash 0, f dash 3 and f dash 8. So again they are asking the derivative at 0, 3 and 5. This time they are using different expression. Okay, so that this means same, that you have to first derivative the function and find the value when your x equals to 0. They are asking first differentiate, first find f dash x. Okay, so let's find the f dash x. F dash x means differentiation of this given function. So let's differentiate it. So d by dx of 6x plus 16x plus 2. So this will be 16. Differentiation of x is 1, constant is 0. So our answer is 16. So f dash x is 16. Now one by one we will calculate f dash at 0. That means when your x equals to 0, your x equals to 0. So when your x equals to 0, what is the functional value? Okay, see f dash x equals to 16. F dash equals to 16. They are asking put x equals to 0. So there is no x here. There is no x here. So putting the value 0 will not give me any change. Okay, there is no x here. There is no x here. So putting the value x equals to 0 in this expression, I will not get anything new. So that means my answer is 16 only. Okay. Secondly, again f dash 3. Now they are asking wherever x equals to x is there, put the value x equals to 3. But there is no x. It is a constant. So my answer again is 16. Now f dash 8. F dash 8. Now they are asking in the f dash x, put a value x equals to 8 and give the answer. So there is no x in the expression. There is no x in the expression. So there is no point to put x equals to 8. Okay, so there will be no change. So the answer will again be 16. So that means it is your constant function, and putting the value or changing the value of x doesn't change the f dash x function because it is a constant function. Okay. So that's all for today's session. I hope you understood the topic well. If you have any doubt, you can contact me through Urban Pro Profile app. And till then, practice and revise. We will meet in the next session. Thank you.